Hello, hello everyone, and welcome
Hi,
to Azure User Group Sweden. Hello, Jonah. How are you?
I'm great. Thank you so much. I'm very happy to be back doing our session this year. How's your New Year so far and holidays, Håkan?
Yeah, it's been really good. It was nice to have some holiday, but now it's equally nice to be back and bring you some more uh, interesting information here. So I'm
Yes.
really happy that we can start our first session with a very interesting speaker here with Hamida Rabai. But before we go into all of that, we could have a quick look here at our code of conduct.
Yes, let me share that. So, before we start our session, we would like to remind everyone that's watching us right now to be nice and friendly, listen with purpose, and be thoughtful with everyone. Be respectful to others. Seek to understand, not criticize. Be curious and open to share ideas, and be inclusive in your comments and questions. So, you can read more about our conduct on the link below. All right.
Yes,
And should we introduce our speaker on the stage? I think
yes. So
to get
let's
started.
let's bring her in here. Hamida is a software architect and also Microsoft MVP for developer technologies. She's also Azure certified and a Microsoft certified trainer. And she is contributing code to projects and also a member of the .NET Foundation. And she is also a speaker and has led many projects to drive change through technological innovations that create business opportunities. And in addition to that, she's a blogger, a speaker, an author, and a technical writer. So welcome to Azure User Group Sweden, Abida.
Thank you.
Yes.
Hello.
Welcome, Hamida.
Hello.
Yes. Great to have you as our first speaker of the year. I know that you're in Canada right now and it's early in the
Yeah.
morning for you. So thank you for taking the effort and time to join us today.
Thank you for inviting me. I'm really happy to join you today.
Yes.
So what will we see in your session today, Hamida?
Today we will speak about microservices. We will speak about Service Fabric in particular and how we can use container in Service Fabric and why.
Yeah.
We will say why because two technologies different, but we will see why and the difference with the Kubernetes too. So we have a lot of information today
Oh, nice.
Yeah,
to
interesting. I'm
discover it.
excited. Yes, I'm excited. So, without further ado, we should give you the stage now so we can get started.
Okay, thank you.
Yes.
Yes. So, hello again. I am Hamid Arbey. So I am as I they already presented me, but you can find my blog, my LinkedIn, and YouTube channel here in this link, where you can ask me, or you can follow my new session, or if you have any questions too, or a new video. So today we will talk at the beginning about the advantages of microservices compared to monolithic applications. Then we will prepare our environment in order to start the Service Fabric demo. In a changing market, one of the main challenges of maintaining the competitiveness of digital businesses remain in IT agility. However, in their current state, computer systems are struggled to adapt to the latest technological developments such as mobility or the Internet of Things and to their new requirements. With a large number of interdependencies of services linked to the lifecycle of an IT project, each modification of the source code of a classic monolithic application can destabilize in maintenance. For this reason, companies has resorted to more optimized scalable architecture, ensuring continuous availability and less costly in terms of research conception and in particular oriented microservices. This change is essential facing the aggressive competition and in particular that of startups which are not yet congested by rigid infrastructure. Before talking about microservices, we need to understand the difference between the traditional application approach and the microservices application approach. Any application is built as a collection of services and can be deployed, tested, versioned, deployed, and scaled. For monolithic applications, scale is done by cloning the app on multiple server or virtual machines. For microservices, scales is done by deploying each interdependently with multiple instances across your server or virtual machine. I highly recommend seeing more details about microservices on Martin Fowler's website. In the bottom here, I left the article. Microservices are very similar to beehives. Within a hive, thousands of bees coexist and help each other for a single common goal, the survival of the colony. The queen, the workers, and the drones, each one have their particularities and must therefore assume very distinct tasks. When developing a server-side application, you can start with a modular hexagonal or layered architecture, which consists of different types of components or layers. Here we have presentation layers. The first one, this is user interface layer. This can be web or mobile or desktop application. A second layer is the service layer. It's responsible for handling HTTP requests and responding with either HTML or JSON or XML for web services, APIs, for example. The business logic layer is the heart of our application. It's the business logic. And the database access layer object is responsible for accessing to the database. Despite having a logical modular architecture, the application is packaged and deployed as a monolith. Monolithic applications are more of a single complete package having all the related needed components and service encapsulated in one package. But for microservices, the idea is really simple. We have It consists to split your application into a set of smaller interconnected services instead of building a single monolithic application. Each microservices is a small application that has its own hexagonal architecture consisting of business logic along with various adapters. Some microservices would expose a REST, RPC, or message-based API, and most services consume APIs provided by other services. Other microservices might implement a web user interface, and microservices are deployed independently with their own database per service, like the case here. So we can have more than a database, SQL or NoSQL or stateful services. Microservices allow us to scale, deploy, and deploy parts of your application independently. They offer great distributed software challenges. But with these benefits, we cannot always choose microservices because they are intended to large, scalable, and long-term distributed application. So do not underestimate the complexity in implementation, maintenance, and testing. We now present the different architecture and patterns of microservices. This table summarizes the modern patterns and technologies to be used like containers. There are many models, much of which are linked or come from the domain-driven design. And we have here Service Fabric. We can find here with technology containers or containers needed, Azure Container Registry, for example, for containers. And here we have Service Fabric that we will talk about it today. Companies face challenges in their passage to the cloud because, for example, there is the optimization of the development of microservices to be taken into account. Similarly, achieving reliable consistency of state and data without latency problems. Monitoring and governance at the globe and granular levels, execution of highly secure application on a large scale, until integration and continuous development. Microservices, Microsoft Azure includes quite a few services to host and deploy microservices. We can deploy our application, build by using microservices on app services. Service Fabric is what we talked today about. Kubernetes service is an orchestrator, container instance, or batch. So we have three major services in Azure. There is Service Fabric, which we'll talk about more in detail during session. It supports microservices developed by any language, and Service Fabric mesh has been retired last year. We also have Azure Kubernetes, which is a container orchestrator containing microservices easy to manage. And finally, we have Azure Function, which is a part of the services we act according to the triggers. So what's Service Fabric? Service Fabric allow you to create and manage scalable and reliable application composed of microservices. So this is why we talk about it. These distributed microservices run at very high density on a shared pool of virtual machines, which corresponds to a cluster. Service Fabric represents the next generation platform for building and managing these cloud level Tier 1 enterprise application running in containers and works with other providers too, like AWS and OpenStack. So we'll see how we can create a local service fabric cluster using SDK service. This cluster will allow us to create service fabric application using Visual Studio and deploy it locally after we will deploy it on service fabric cluster in Microsoft Azure. But we need to understand the structure of Service Fabric cluster. So Service Fabric cluster is network connected set of virtual machines into which your microservices are deployed and managed. A cluster is a set of nodes that are virtual machines, and node numbers depend from the use of clusters. In development phase, you can use only one node, but in production, you need to have more than 5 nodes. Every node has an operating system Windows or Linux with a runtime, and a node can host multiple applications. It depends it depends from the research available in the virtual machine. So Service Fabric can be run anywhere. You can create clusters for Service Fabric in many environments, including Azure or locally, on Windows Server or on Linux. You can even create clusters on other public clouds. In addition, the development environment in the SDK is identical to the production environment, with no emulator involved. In other words, what runs on your local development cluster is deployed to the cluster in other environments. Service Fabric is an open source project and is used in many services in Azure infrastructure, as well as other Microsoft services, including Azure Event Hubs, Azure Cosmos DB, Azure SQL DB, Dynamics 365, and Cortana. The major subsection of Service Fabric can be seen now below here. As you can see, here for Azure, and here we have for Windows, like Cortana, Skype, Power BI. Now we'll talk about the architecture of Service Fabric. So Service Fabric, as you said, is a platform that makes it easy to build and deploy microservices-based application handling both stateful and stateless operations. It will run on any Windows system, and there is also a Linux version, which means that it's portable across multiple cloud environments, including Amazon Web Services, OpenStack, and VMware. Apps that are created in Azure Service Fabric environments are made up of granular microservices, small chunks of code which are uploaded and run separately. These microservices communicate with each other using Service Application Programming Interface APIs. Because microservices are modular, it's possible to scale each component of an app separately, which simplifies the process of rolling out changes in contrast to traditional monolithic architecture. So Service Fabric provides lifecycle management capability to microservices-based application. The microservices are hosted inside containers that are deployed across the Service Fabric cluster. Using containers instead of virtual machines means a massive increase in density, and greater still, the density can be achieved by moving from container to microservices in these containers. So this is the schema of the architecture. The first layer from the bottom here, we have transport subsystem is responsible for providing secure communication channels between nodes in Service Fabric cluster. The federation subsystems above, it helps logically group physical or virtual nodes into a cluster so that can be managed as a unit. This helps Service Fabric with tasks such as failure detection, leader election, and routing. Reliability of the workload hosted on Service Fabric is managed by Reliability Subsystem. It owns the responsibility of replication, research management, and failover. The hosting and activating subsystem manages the lifecycle of the workloads on every node, and the management subsystem is responsible for managing the lifecycle of application. The testability subsystem helps developer test their workload before and after deployments. And server location of services hosted on Service Fabric is managed by communication subsystem. The top three boxes capture the application programming models and the application model available for the developers to consume. And you can have more application models is discussed in later after you can see them in the documentation of Microsoft. Monitoring and diagnostics are critical to developing, testing, and deploying workloads in any cloud environments. For example, you can track how your application are used, the actions taken by Service Fabric platform, your research use with performance, counter, and the overall health of your cluster. You can use this information to diagnose and correct issues, prevent them from occurring in the future. So we'll talk here. We can see here the two monitoring tools that we can use it. We have the Service Fabric Explorer that we can use it locally and remotely in Azure. And we have Azure Monitoring, where we can have more features to do diagnostics for Service Fabric and for all your machine. So before starting our demos, we need to have all these requirements in order to be able to configure your Windows development environment to create Service Fabric. So for the requirements, we need to have Windows 10 or the last one, 11, is required to do the installation of Docker installation. It should be not home, not familiar. It should be professional enterprise version for Windows. We can use Visual Studio 2022 or 19 or 17. We has built in support for Docker, .NET Core, SDK, Microsoft Service Fabric, Docker for Windows, and Docker tools. So here today we will start by setting up our Windows development environment to build Service Fabric. The first demo, so it will be to set up a local Service Fabric. After we will create a Service Fabric using Visual Studio. We will publish a Service Fabric in Visual Studio. We build existing .NET Service Fabric application. We clone it from samples of Microsoft. We will deploy a Service Fabric application to a cluster in Azure. We will execute Docker container in Service Fabric, and we built our container in Service Fabric using Visual Studio. We will start by setting up our Windows development environment to be able to build Service Fabric. So let's start. We need to install Visual Studio 2022. You can also use 2019, 17. So it includes Service Fabric template in Visual Studio that we can use it to create and build Service Fabric application. We need to install the Microsoft Azure Service Fabric SDK. It's similar to this one using Web Platform Installer. The 5 is the latest version, so you can install it. And if you have only just 2000 Visual Studio 2015, you can install the Microsoft Azure Service Fabric SDK tools. It's the link for SDK installation only. So I left another link here where you can install the Azure Microsoft Azure Service Fabric SDK, the entire package. Now we'll set up a local Service Fabric cluster. So here in Windows, after installing the SDK, we will try to do searching for Service Fabric local cluster. In the button here, you have an icon here to start our cluster, and we click on Manage Local Cluster. We have a Service Fabric Explorer. We will see that in detail after. Now we will create our Service Fabric using Visual Studio 2022. I recorded our demo to be able to have the many demos to test the entire features of Service Fabric. So here we have Visual Studio 2022. We click on Create a new project, and we try to check for Fabric here. It's really simple to search templates in Visual Studio. It's the same thing on Visual Studio 2019. So we give a name to our project. We select the framework, .NET Framework. And here we have really many options to select stateful, stateless service that we can create, actor service. Here we have the container, the stateful, ASP.NET Core, the container, that we will see after. We can also use the old .NET Framework to create Service Fabric. So here we give a name we will start by stateless. It's really simple. We have our application. So in the top, we have a project with a logo of Service Fabric. And we have here the configuration part. It's simple. It's a simple service that we can use stateless that inherit from stateless service that we can use it here. And we can build our application to be able to start and see how we can deploy it and what is really these applications. So after building, we will start this application and we will open a Service Fabric Explorer to see how it's the monitor that we can use it to see the state on the health, to diagnose our application. We just started our application. As you can see here, we have the output of Service Fabric tools that we can use it. Here we have Service Fabric Explorer. We have our application that already deployed. We have service, our simple. So we have only used one node in our case. And you have the application here, the service. So as you can see, we can see if you have an error, warning, or it's green. It's really, we don't have any problems. So it's really easy to use it to find where is the issue. Here we have the details related to our node. We have only one node. Even we stop debugging, our application will disappear from the Explorer here, as you can see. For these reasons, to keep our application deployed, we need to publish it. So now we will publish a Service Fabric in Visual Studio. We come back to Visual Studio. We right-click on our solution, click on Publish. Here we have many targets profile. If we will publish to the cloud, we need to select the first one, but in our case, we will publish it locally. So we have two application parameters, two parameters files that we can find them here in application parameters, and for startup service parameter file here. So it's a local cluster. We can create more than a cluster. In our case, we have only one node. We configure it only one node, but we can change it to more than one node. Locally, we have one node and 5 nodes. We click on Publish. It takes few seconds to be deployed, and it depends from your application. In our case, it's a really basic application. Here we have the application deployed. Even we stop debugging or we close our application Visual Studio, it's always deployed in Service Fabric. Now we will build a .NET Service Fabric application, and we will clone from here Azure Samples. You can find it in this link, Service Fabric.NET Quick Starts here. It's a really simple ASP.NET Core application that we can use to test Service Fabric before starting building your own application. So I will start by do Falk here. And I will copy this link to clone it after using Visual Studio. So when I clone it here, we have this application here, clone repository. I will use now Visual Studio 19. So we clone the repository, we select a path, and we click on clone. And the cloning is done in few seconds already. It's really simple. So we have the entire application. It's for voting. Here we have the voting application, the Service Fabric, and we have voting data that include our controllers, let's say the business part, and we have the user interface part, voting. This is the voting data, and this is the voting web that include our views that we will use it to see how we can vote. It's an application for vote. Let's see this application. So to understand really this example. So here, as you can see, the application is created. It will be added to Service Fabric Explorer. Here we have our application. So we add some votes, really simple. So vote 2, for example, we will add and remove this vote. We have here, we can add more than votes. And in Service Fabric Explorer, we can have 2 applications in our case. So the first one, the second one. So you can have more than one application. So So every application will be added in Service Fabric Explorer. Now we'll deploy this Service Fabric application to a cluster in Azure. Previously, we deployed locally. Now we will see how we can deploy to Azure. We click on Publish. Here we have Microsoft account. We will select the first one this time, Clouds. So we need to click on refresh. Here we will create our Service Fabric using Visual Studio. So here we can define the number of nodes. As I said before, we need to have more than 5 if we are in production. Here we need to add certificate passwords to create a certificate to be able to deploy our Service Fabric. It's you need to do that to ensure more security to your service. Here we have your certificate output, and we need to have our virtual machine details. As we said before, the cluster is virtual machine. Every node will be deployed in a virtual machine. Every node is a virtual machine. And here we will add a port to be able to see 80 to be able to see our application deployed on Azure. Here we need to check the location here. As you can see, we need to update the location in our cluster. So we go back to cluster here and the location. I will use East US, for example, here. And here we have all virtual machine size. So the virtual machine image, you can select Windows or Linux, and we have more than value. We can add here the cluster name. I will give a cluster to the name, change the name. I already have this name, and we click on create. Here we have all the information related to our cluster created. So to deploy our Service Fabric to Azure, we can have a few minutes, and here we have the link, and we click on publish. Here we go back to Visual Studio, to Azure, the portal of Azure, and we check the Service Fabric created here. So here we have the research group that we already created, voting, that we are enabled to check them. Voting cluster. We go to the research. As you can see, we have many information here. As you can here, we have the VM or research needed to create our cluster, and we have the Service Fabric cluster. We copy this link to check for Service Fabric Explorer. Here we have our certificate that we already added before in Visual Studio. And here we have 3 nodes. No application for now because we didn't upload our application, 0 application. We need to refresh to have this application. Now the application is uploaded. We have this application that includes voting data and web. And we will check for the application here. So we have this link. We click on, we find it in Azure portal. So as you can see, our application is deployed without any problems. I go back now to the presentation. And we will talk now about how we can execute Docker container in Service Fabric. So before we only tested stateful service and .NET application. Now we will see how we can use a container, Docker container in our application, in our Service Fabric application. So what is Docker container? So the container is a tool that makes it easier to create, deploy, and run application by using a container approach. These containers are lightweight and take less time to start than traditional servers. These containers are also increase the performance and lower costs while offering proper research management. Another benefit to using Docker is that you no longer need to pre-allocate the memory to each container. If we come back to 5R for containers, if we set 5R, here we talk about replace, rehost, refactor, re-architecture. So this we talk about this one. You can see how we can deploy if we want to rehost the first one, for example. For rehost, if we have existing application that we don't want to do any modification or refactoring in our architecture. We want to keep this application, so we can keep them. They are in on-premise, so we can just rehost. Or here refactoring. So we want to do lift and shift for the first one to container, or just to refactor, or we rebuild to use the microservices approach. If we decide really to re-architect and for a new application, we have to build patterns to adopt cloud native strategy in the future. So why we need to use container in Service Fabric? If we have IaaS lift and shift, you can put an existing ASP.NET MVC app in a container instead of migrating it to ASP.NET Core. This ASP.NET MVC apps, we talk about old .NET framework, depend on Internet Information Service, IS. You can package this application into container images from the pre-created IS image and deploy them with Service Fabric. So the second reason is to mix container and Service Fabric microservices. You can use an existing container image for part of your application. For example, you might use the Nginx container for the web frontend of your application and stateful services for the more intensive backend computation. And in the end, another reason is to reduce impact of noisy neighbors, say services. So we can use the research governance ability of containers to restrict the resource that service uses on host. If services might consume many resources and affect the performance of others, such as long running query-like operating, considering putting these services into containers that have resource governance. So Service Fabric supports the deployment of Docker containers on Linux and Windows server containers on Windows Server 2016 and later, along with the support for Hyper-V isolating mode. Now we will build and execute Docker container in Service Fabric. We have another demo that we can see it related to container. As we said before, we need to have Docker desktop installed already in your machine to be able to upload our images locally. We go back to Visual Studio, we click on create a new project, Service Fabric application, I give a name. We click on create, and here we already see that before container. We need to give a name to our service name. I will say container, for example, so simple. And here we need to have the image name. If your image is public image, we don't have to add username, host port, container port. We will use in our simple ASP.NET Core 5 here, simple. It's public. We don't need to add a username, but you can also use your own image. We will see how we can update our images too. So here we go back to Visual Studio to see this part here. As you can see, the image will be added here. You have the image name, and you can update this image. If we added the username, we will have another part inside the container host, and you can upload your application. You can publish your Service Fabric application as Service Fabric or as Azure Container Registry too. There are two main types of services you can build with the Service Fabric. Today we cover it. For example, the stateless service. So the stateless services we use it in our first demo project. No state is maintained in the server. If the service longer-term state is stored in an external database. This is your typical application data layer approach to building services that you are already likely familiar with. But we can use stateful services where the state is stored with the server, with the service, allows for state to be persisted without the need for an external database. So your data is co-located with the code that is running the service. You can see the difference here. Here we have the stateless service, and here we have the stateful services. So it's recommended to use the stateful service to ensure always the high availability of your application. So today we talked about microservices overview. We get an introduction to Service Fabric, the architecture, but you can see more in Microsoft documentation. We prepared our environment for demo. So we set up a local Service Fabric. We created a Service Fabric using Visual Studio 2022, but it's the same for Visual Studio 2019. We published Service Fabric in Visual Studio using an example that you can find more than example in Azure samples in GitHub. We talked about monitoring, diagnostics. We use it for monitoring today. Service Fabric Explorer that we use it locally, and it exists in Azure. But you can use Azure monitors if you need more information about your virtual machine, really. But the Explorer is related to your application. We built a .NET Service Fabric, we deployed it, and in the end, we built and executed your Docker containers in Service Fabric. So you need to create an application, the container application before you upload your application. You deploy it in Docker Hub or in Container Registry if you want to be private images, and you can use it in Service Fabric application. You can deploy it after as Container Registry or in Service Fabric. I leave all these references here. So for downloading Service Fabric SDK, you can have more simple and complete solution with the Service Fabric if you need to understand more, because let's say for 45 minutes to talk about all this information, it's not easy to talk about it really faster. And we can learn from tutorials and videos, deploy samples. Here we can try Service Fabric, the link of Service Fabric, and you can create a production cluster if you need to really use your Service Fabric as a production in production modes. Thank you. Now it's time for questions.
Yes. Hi. Yes. Thank you so much for your great session, Hamida. Yes, we do have questions from our audience. Let me show. First questions that we have is from Ashish. Is it mandatory to create a Service Fabric project in Visual Studio if I need to deploy containers on a Service Fabric cluster?
Okay, in Visual Studio, yes, we can use the template, but we can use the template to create the template inside Visual Studio, but you can have the same template in Visual Studio Code. So yes, you need to use the template already prepared in Visual Studio to be able to create the Service Fabric application.
Thank you for that. I hope it answers your question, Ashish. We have another question from Ashish as well. Or should we take another question, Håkan?
We can take the next question here from Ashish. So he says, it looks like we're deploying without creating and publishing container images. Is this correct, or has Visual Studio has this abstraction implemented?
Yes. So as in our example, we said that we will use an already public image. We need if we want to use our own image, we need to create a container application to deploy it in Docker Hub if it's really public, or in Azure Container Registry before to deploy it in container registry. And we copy the link, let's say the link of your image with your username and the port, container, the host, everything. So we need to create before your container, and it will be used after in your Service Fabric application. As we seen before, it's really a block in your configuration part where we have container hosted and only the link of your image. So we need to create before our container. After, we just call this add this link of your image inside the application.
Okay, thank you for that, for the answer, Ashish. Hamida. Let's see. That we have another question from another audience, from Pradipta Guri. I hope you pronounced your name correctly. But nice presentation. But I could not understand the advantage of using Service Fabric instead of Azure Kubernetes service.
Okay, when we presented the services of Azure, we presented Service Fabric as a part, and Kubernetes. We don't. I can say that we use Service Fabric and not Azure Kubernetes service. It's not the same thing. As we see here, the Service Fabric is used for really distributed big application. Microsoft use it too for their own application. But for Kubernetes is just an orchestrator that we use it with containers. If we have an application, container application, we need to use Kubernetes to orchestrate between all containers here. So in every solution we have, let's say, it depends from your solution. So I will use Service Fabric with containers, or I will use containers with Kubernetes. So it's not the same. I don't know if I answered to her questions, but they are different technologies, as we said. Use it for microservices for your services. It depends from your needs and your application, if it's really distributed or not. We can't use the Service Fabric for small applications, so there is no sense here in our case. In this case, so we have really big application distributed that request really many memory. It will be requested by many users. It's deployed in many places. It requests many management. Let's say here in our case we will use Service Fabric, but for other case we will use containers with an orchestrator that can be Kubernetes service in this for Azure, for example.
Okay, and then we have next question here is from Ashish.
Okay.
He says that there was no Docker file. How can we deploy or configure multi-container apps in Service Fabric like the ones we deploy using Docker Compose YAML file?
Okay, it's always related to containers. There is no Docker file here, yes, because we will use our image. So it can be one image and more than one image. So we can have many application with many images. So we don't have really a container application inside inside the Service Fabric application. Service Fabric, it will be like, let's say, like a place to use the image, but you will have your own application, container application, that will include your Dockerfile, your Docker Compose, that is already deployed to Azure, let's say Azure Container Registry or Docker Hub. It depends from where you will host your image. After we will get the image, and it will be called by your Service Fabric application when we deploy it. So there is no application, container application. It will be another application, not inside the Service Fabric application. This is the difference. So we two different projects will be.
Okay, thank you so much. Hope it answers your question, Ashish. We also have another question from another audience, Gabriel. So Gabriel asks, in your experience, have you found any entry barriers for adopting Azure Service Fabric in your client projects?
Any entry barriers? It's mean any problems? Let's say, or is that the questions? I think.
I think so. Maybe entry or beginner
Okay.
barriers
Yes.
or challenges, maybe.
Challenges. Yes. Yes. I think. Yes. We can find many really challenges to implement Service Fabric in a current project because, as we said, some challenges is to really understand the use of Service Fabric and how we can implement our services inside or our application inside the Azure Fabrics, inside the Azure Fabric, the application. Currently, I didn't use it any any project with the Service Fabric. I use it just I learned it for me and some samples of Azure. I don't have a big experience with any client for now, for unfortunately. So I can't really answer you for these questions.
And then actually, Ashish, who was asking about the Docker file, he came with a second comment here. So he says, oh, got it. So we can create and publish our containers and then create a Service Fabric project to deploy them on Service Fabric cluster, if I understand that
Yes,
correctly.
it's right. Yes, it's another project. Yes, it's okay. So this is
nice.
my answer. Yes.
Yes. And Ashish also says, thank you so much for a great presentation and introduction to Service Fabric.
Thank you.
Yes, yeah. And we also have like a friend, one of our great friends in the community, Stephen
yes.
Seaman, is also here with
Thank
us today. So glad you could join us live today. Thank you.
Thank you.
And
Thank you.
great presentation. We have a lot of feedback coming. One of our friends also in the community, Ernst Arthur, said awesome presentation and good questions from everyone.
Yeah.
So
yes.
All right. I think we don't have any more questions, Håkan. Did I miss something?
No, I think that was it.
Yes. Yeah. Yes. So we only have like 6 minutes before the end of our session. Would you like to stay with us, Ramida, when we announce our giveaway winners? We did it already, but we want to reveal it again. And after the session, if you have time, would you like to join us on the backstage just to chat a bit?
Okay.
Yes. All right. Yes, let's see. Where is that? So I hope everyone has learned a lot from Hamida's session. I myself did. How about you, Håkan?
That was very, very information rich.
Yes. So we would like to share this small image to congratulate our winners for the Christmas 2021 giveaways. Congrats to Gabriel Vergara, Ahmed Tariq, Karel De Winter, Ashish Bagel. Yes, congratulations, and some gifts and giveaways are already on your way. thank you for sending us your feedback. Yes.
Yes.
All right, Hakan. Do you have any, Hamida, Hakan, do you have any last words or message to our audience?
Hamida?
Yes. Thank you. Okay. Thank you for joining my session today, and I hope to give more sessions
Yes.
next time. Yeah.
Yeah.
And
Maybe.
yeah.
Yeah. Go
And
ahead.
we can also mention here that in our next session, which is 2 weeks from now, on February 5th, we will have a session by Robert Strand, and he will talk about how we can get started with Terraform and Azure.
Okay.
Yes, that's also interesting. Yes, we have many sessions coming in the coming weeks. Yes. Yes. All right. Yes, I guess it's time. It went too quick. I guess it's time to say goodbye.
Yes.
Yeah.
I wish we could
Yeah.
stay longer. It was
Yes.
interesting. But before we let you go, we end our session, or Hamida, do you have any upcoming events or interesting sessions coming that you want to share to our audience?
No, for now. For now, we started the year for organizing. So you can follow me on LinkedIn to know about next sessions. But we have maybe a session in March with Microsoft. So I will share about this information for Canada, for Developer Canada. So I will share all the next week, let's say, about the
Yes.
next session. We just started the year planning our session too. Okay. Thank
Yes.
you for asking me.
Yes. All
And we can
right.
also mention before we close off here that our call for papers is always open. So if you look in our our outro, you will have a QR code, and then you can scan the QR code with your camera or with your mobile, and then you will get to our Sessionize page. And we're open to any session that has to do something with Azure to do. And also, if you're a new speaker, you shouldn't be afraid, because both me and Jonah will be able to help you and work with your proposal or with your presentation.
Yes, definitely. Yes, thank you so much. And we're saying goodbye now. So yes, I feel dramatic. Just kidding. Yes, but thank you so much,
Thank you.
everyone that tuned in live today. Hamida, it has been great. So we look forward to see you again in other community events. And happy
Yes.
weekend to everyone.
Yep.
Bye
Yes.
bye.
Happy,
Bye.
happy weekend.